Okay, we are going to talk about the atom. I'm going to keep this as straightforward as possible. So here we go. So the atom consists of three basic parts. Inside a core, or nucleus, there we find protons, and we find neutrons. Now, protons have a positive charge, neutrons have no charge. And they both have a mass of 1 atomic mass unit, which is basically how much a hydrogen atom weighs. Now, surrounding this very dense core are electrons. Okay, and the electrons are very light, and they have a negative charge, and we'll say that they have basically no mass. Very, very light. So the electrons swirl around this dense core, and there's a lot of space between the electron and the nucleus, which contains the protons and neutrons. Now, for understanding the symbols of atoms, each atom has its own symbol. So this is hydrogen, right over here. This is helium. This is lithium. This is copper. This is cadmium. And this is arsenic. You'll notice that each symbol has two numbers. Now what I've done is I've put the top number is the smaller number, and that refers to the atomic number. Okay, and the atomic number is actually the number of protons, and this is what identifies each element. So if it has 1 proton, it's hydrogen. If it has 2 protons, it's helium. If it has 48 protons, it's cadmium. The bottom number, this number over here, is the mass number. Now that is actually the number of protons and neutrons. So in hydrogen's case, it has a mass number of 1. So if we actually fill out this bottom chart, atomic number is 1, the mass number is 1, so it definitely has 1 proton, and the number of neutrons must be 0 because these two numbers, 1 plus 0, have to add up to the mass number. Now in helium's case, helium has an atomic number of 2, it has a mass number of 4, it has 2 protons, and therefore 2 plus 2 would give you your 4, so it must have 2 neutrons. And lithium would have, say its atomic number of 3, it has a mass number of 7, so again it has 3 protons and 4 neutrons. Again, these two numbers have to add up to 7. Copper has 29 protons, it has a mass of 64, so it has 29 protons, and then 35 neutrons. 29 plus 35 again has to equal your mass number. Cadmium has, sorry, that should be 90, I think that's 112. Well, that should be 112. I'll have to double check that. But cadmium has an atomic number of 48. It has a mass number of 112. I could be wrong on that one. So again, it would have 48 protons, and then you're looking at 64 neutrons, because again, these two have to add up to 112. I'm not sure if cadmium's mass is 112. I'll have to double check that. And the last one is arsenic. It has a mass number of 75. It has an atomic number of 33. So the number of protons is 33. And then 33 plus 42. So it has 42 neutrons. Is the mass number. Now, when these atoms are neutral, neutral means that the number of protons is equal to the number of electrons. If it's not, then it's an ion, and we'll deal with that next tutorial. So in this case, the number of electrons of a neutral hydrogen atom is 1. Helium would be 2, neutral lithium 3, neutral copper 29, neutral cadmium 48, and arsenic, 1 neutral, 33. Now you may notice that when you look at the periodic table, the mass number isn't exactly a whole number. It might be, for example, hydrogen 1 point something, or helium would be close to 4, and lithium would be close to 7. I believe it's like 6.9. And that's because there are things called isotopes. So what an isotope is basically an element that has different number of neutrons. Okay, so for example, this is still lithium, but it has less mass because it only has 3 protons instead of 4. For example, hydrogen could have no neutrons, but it could have 1 neutron, which means it would be heavier hydrogen, but it's still hydrogen. So once again, the atomic number defines the element, but it could have a different mass. In that case, it would be considered an isotope. Okay, so that's it for the atom.